Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haris bin Azari and we are from Group 3 and we present for our group assignment for unknown resistance and temperature of thermistor. Our group consists of 3 members, which is Raj, Amir and Haris. So for our meeting, we already held 6 meetings, which is 23 and 30 November, 14, 21 and 28 December and 4 January. So now I'll proceed for problem introduction. For this group project, the authentic problem chosen is based on the unknown resistance and temperature of thermistor, which is categorized in an electrical engineering problem. The temperature measuring device is known as the thermistor. According to the principle, the electrical resistance in the thermistor changes with the change of temperature of the thermistor. This project is aiming to determine whether the thermistor is calibrated properly or not. We use 2 methods from 3 methods that we learned in chapter nonlinear equation. The method that we use is secant method and Newton-Raphson method. According to the method that we use, the iteration needs to be found out in order to estimate the roots of the equation. The authentic problem and the real data that used is based on the sources from the internet and it taken from the link that we shared in this slide.
Good evening, my name is Manraj Chandran and I'm going to present you about the manual solution of our group project. First of all is the secant method. This is the manual calculation for the secant method. The first step is to simplify the equations. The formula for the secant method is x equals to AD minus BC over D minus C. Then get the values for the secant method table. So for final step is getting the approximate error. So this is the formula. So I'm going to the Newton-Raphson method. So the first step is to simplify the equation and then differentiate the equation. The Newton-Raphson formula is x1 equals to a minus b over c, a, b and c. Then we have to fill the Newton-Raphson table. I equals to 0, r equals 14,000, fr, f differentiated. Final step is getting the approximate error. The formula is the same as the secant method. That's all from me, thank you.
For the software solution, is the coding for the secant method. So we write the function in the MATLAB. So after we run the simulation, we will get a table of the iteration, which is we can get the solution after 4 iterations and the root is 13078.408. To that, for the coding for the Newton-Raphson method, we write the function in the MATLAB. After we run the function in the MATLAB, we will get the table and the iteration after 4 iterations, and the root is 13078.408. So this is the demo simulation of the MATLAB for the secant method. We will run this simulation and the output table will be shown in the workspace. For the Newton-Raphson method, we will do the same method and it will show the table of the simulation in the MATLAB.
For the conclusion, for secant method, 2 comparisons of secant method using hand calculator and MATLAB values are a bit different from one another. Although not quite different, the result of these 2 methods are comparable. The calculation has both even and odd number, which is a problem. Both systems have the same amount of 4 iterations, which is the measurement of how frequently something has been done for each system. Newton-Raphson method. The hand calculated Newton-Raphson and the calculation made with MATLAB values are almost the same. Although they are almost the same, the findings from these 2 are not identical. For manual calculation, there are 2 iterations, whereas 4 are when using a computer program. The best method that we discover is that the Newton-Raphson technique provide the simplest way to obtain the precise value of the resistance by comparing the two values of percentage of absolute relative error. The absolute relative error for Newton resistance method and secant method are approximately 0.2370 and 0.0153.